So, the last movie looked at metadata versus data. Now we're just going to look at data and start putting a realistic or human face on it. So here we have a set of tables. And guess what? It represents music acts at venues. So we have a show, we have a venue, and then we have the act, the category of the act, the tickets that are sold to the people who come to see the show at the venue. You have any supporting acts, and then the ticket prices. So what we actually have here is a bunch of tables or a pile of data that is unrelated. It's not connected, not yet. The table defines the structure of an object, the metadata. So here we have the venue table with the name, the city, the state, the country field, and the venue ID field. If we go back, we'll see the venue table right here. So, now let's go forward again. As you can see, the data is stored inside the structure of the table. The metadata table structure applies an enforced structure to the data. Every iteration in the table is a row of data, which is also known in relational database modeling parlance as a tuple. And again, we're actually looking at the table structure here, but we've added in things like data type, size, scale, nulls, default value, etc. This is actually not the venue table, but this is the show table. If we go back again, we'll see that the show table has a bunch of IDs from other tables, actually, incidentally, which you'll understand in a minute, and a show date. Here's the venue table with name, city, state, and country. Let's go forwards again. As you can see, we've got a number of IDs from different places, plus the show date. Their data types are numbers. In other words, you have to have a number in that field, and you have to put a date in there. The null value simply means that you can add a show date value of null, which in this case may not actually make sense, but it doesn't really matter at this stage. Here you can see that a table is actually two-dimensional, because looking at it in a horizontal and a vertical way, you can see that you have the fields defined across the top, and then the data filled from top to bottom. The fields are defined horizontally, and the data is filled in vertically. It's another way of looking at it. It's just like a spreadsheet. What you end up with is the venue and the show table, for instance, are related to each other. They are connected. So you can see that tables are related by what I like to sometimes call, very simplistically, parent-child relationships. A venue has many shows that happen at the venue. There are many concerts going on at a venue over any particular period of time. The child tables contain repetitions of the parent. So what you do is you remove the repetitions from the child table, and you simply put a key value or an ID. So venue ID gets duplicated in the show table, allowing you to link back to it. What that does is it allows you to separate show and venue data and not duplicate the name, city, state, and country for every single show that's ever occurred at that venue. So you're basically removing the duplication of 4 fields per show date and replacing it with 1 field, venue ID. And you link the parent and child with a copy of the parent identifier in the child. What does the relational database model do? It organizes data, for one thing. It also makes things a lot faster because it breaks up the data into logical pieces, allowing you to access specific logical pieces, small chunks of data, and it also reduces the duplication immensely. One of the biggest factors with a database and the speed of a database is the amount of disk that you're reading and writing at the same time. It's easier to search it because it's all broken up into logical pieces. Yet again, it saves space because it's broken up and there's no duplication, well, much less duplication. There's a lot of terminology in relational database modeling. An entity is the same thing as a table. A relationship is the thing that connects the entities together. Attributes are the fields in a table, also known as fields, columns, The data types define the way that data is structured. So here we have different data types. We've got chars, varchars. A char is a fixed length field. A varchar is a variable length field. Char and varchar both contain strings. Nchar is a special type of string, so is nvarchar2. A number needs a number. You can only have digits 0 to 9 in there. A date must have a structured date. A long is a binary object, as is a raw. There are many other data types available.